Hello everyone, welcome back to the channel. You know how sometimes you visit a website and it just instantly loads? Or you scroll through an app and the data is right there? A huge part of that speed is thanks to caching. But data isn't just cached in one place, it's stored at multiple layers throughout the system. Today, we're going to explore all the different places your data might be cached as it flows through an application architecture. And then, we're going to tackle a really important question about sensitive data. Let's look at the journey data takes and where it gets cached along the way. Client apps, it starts right here, on your device. Your browser or mobile app has a client-side cache. When you request data for the first time, the server sends it along with instructions on how long to keep it. The next time you ask for that same data, your client app checks its local cache first. If it's there and not expired, BAM. Instant load. CDN, Content Delivery Network. Moving further out, we have CDNs. These cache static web resources like images, CSS files, and JavaScript closer to you geographically. Instead of going all the way to the main servers, your client can grab these resources from a CDN node nearby, making things much faster. Load balancer, even the load balancer can cache resources. This helps reduce the load on your backend servers by serving frequently accessed content directly from the load balancer itself. Messaging infra, like Kafka. If your architecture uses message brokers, data gets cached here too. Message brokers store messages on disk first, allowing different services, consumers, to retrieve them at their own pace. Depending on the retention policy, messages are cached in Kafka clusters for a period of time before being removed. Services, your actual application services have multiple layers of cache within them. There's the superfast CPU cache. Then the RAM cache, in-memory cache. Sometimes, services might even have a second-level cache storing data on disk for quicker access than going all the way to the database. Distributed cache, beyond individual services, you often have a distributed cache like Redis. These hold key-value pairs for multiple services, typically in memory. This provides much better read/write performance than hitting the database directly and is a common place to cache frequently accessed data shared across your application. Full-text search, if you're using full-text search engines like Elasticsearch for document search or log analysis, a copy of data is indexed and cached within the search engine as well to enable fast searching. Database, even the database itself has different levels of caches. WAL, write-ahead log data is written here first before being applied to the main storage structure. Buffer pool, a memory area to cache frequently accessed data blocks and query results. Materialized view, pre-computed query results stored as tables for faster querying. Transaction log, records all transactions and updates. Replication log, used to track changes for replicating data to other database instances. Let me know your thoughts in the comments below. This is a complex challenge in modern system design. Thanks for watching, and I'll see you in the next video.